Hi there, and welcome to week 3. This is the final episode or lecture for this week. It is mini lecture number 8. And in this episode, we will be speaking to strength program design. So, a number of variables should be considered in designing the muscle strength and endurance portion of a rehab program. And exercises may progress from being more static or isometric to isotonic to multiplanar and to more performance-specific movements. This actually goes back to our first week of lectures where we had the rehabilitation pyramid, where you identified a series of goals and over time, patients would be able to progress through a series of different therapies or modalities or exercises to build ultimately both function and, in some cases, performance. Now, the rate of progression will rely on multiple factors. So, for example, an individual who is sedentary and older may take longer to progress than someone who is younger and, say, a high performance athlete. Strength goals may also focus on progressions through either modifying the number of sets, increasing the number of repetitions, or increasing the weight or the load. Now, if we take a look at this next slide, these are recommendations for improving muscle strength, endurance, and power. So you can see the various goals. You can see the repetitions and the ranges given and the intensities. Now, obviously, once again, the repetition range is somewhat variable and it will depend on the individual and perhaps their age or their trainability or whether we're speaking about a high performance athlete. Now, what is clear is that as the repetitions decrease, the amount of resistance that a muscle can tolerate will increase. And there is also, for those of you who are interested, a position stand or a paper that is specific to strength training that has been put out by the American College of Sport Medicine. And this paper provides estimates on the amount of resistance to be used. Now, with any good rehabilitation program, there will be the concept of progressive overload. And so to produce strength gains or to continually produce improvements, the load must be progressively increased. So basically, as a patient's strength improves, the exercise difficulty must also increase to provide that overload. Now, early and rapid strength gains are owing to improved neuromuscular recruitment and efficiency, whereas later gains are made primarily through muscle fiber hypertrophy. So the graph on the right-hand side of the screen nicely highlights how we see strength gains over time, particularly if you were not to provide that progressive overload. Many rehab programs will estimate with a one repetition max or 1 RM, but more commonly you will see a 10 RM. And so we saw those kinds of guidelines in the preceding slide, and you will see it on when we speak at the end of this lecture about some of the various examples of systems for exercise progression. Now, I'll add one final note. When a muscle cannot actively exercise or the patient is restricted from moving the injured area, cross-training can produce some strength gains as well. Now, let's take a moment, though, to discuss this concept of progressive overload. So there's something known as the SAID principle, which stands for specific adaptations to imposed demands, which is essentially highlighting the idea that a muscle will adapt and perform according to the demands placed upon it. And the examples that we provide here are, if you have a high load with a low repetition used, then muscle strength is most likely to increase. Conversely, if you have low loads with high repetitions, then endurance will increase. At the end of the day, the exercises should mimic the sport or work stresses. So there should be some level of specificity to the exercises that are being performed. And the rate of the strength gains, once again, will be related to neural adaptation and the reflex inhibition. Now, finally, I will provide a few examples that have been highlighted in your textbook on program progression. So there are these different systems that have been published. There's the DeLorme and Watkins exercise progression, the Oxford Technique exercise progression, and the daily adjusted progressive resistive exercise program as well. Now, I'm going to show you a more specific breakdown in a moment, but one of the key take-home points here is that no matter what system for exercise program progression that one is using, that these systems all produce a gradual or a graded overload to optimally stress the muscle to cause an increase in strength. And also, an overload should always be applied with the therapeutic exercise to produce strength gains. So let's have a look at these various systems that have been published. So first, if you look at the DeLorme and Watkins strength progression, you can see that they advocate for 3 sets, 10 repetitions, and working first at 50% of one's 10 RM, and then progressing to 75% and 100%. Now, interestingly, the Oxford technique and the physicians who created it criticized the preceding progressions by DeLorme, as they observed that many patients were too fatigued to perform a third set of 10 RM exercises. And therefore, rather than seeing a progressive increase in a weight, so rather than it being 50%, 75% to being 100%, they actually inverted or reversed that order such that the patient actually performs and begins their first set by performing 100% of 10 RM. So the weight is 100% of one's 10 RM. And they also perform 10 repetitions. So that's fixed, as is the number of sets performed. Now, finally, you can see that the daily adjusted progressive resistive exercise program is laid out on the right side of the screen. Now, it does mirror the DeLorme-Watkins strength progression in that the percent of working weight actually increases. However, what you see is that the number of sets also exceeds that of the other two techniques, in that it really promotes individuals to do additional sets and additional repetitions if possible. So it is much more prescriptive in nature if you look at how they adjust the guidelines as well, and that's shown in the bottom right of your diagram. And that concludes this lecture episode.